Hello, welcome to Math 1324. This is Chapter 5, Section 1, Example 8. In this question, we have, suppose $20,000 is invested at an annual rate of 9% for 10 years. Find the future value if interest is compounded as follows. Now notice that we've got several different things. We've got annually, quarterly, monthly, daily, and continuously. Now the continuously is actually going to be a bit special. But these four are really not that bad. They're actually all the same formula. Still just this formula for all of those. So for A through D actually, we have A, P, R, N, and T. N is going to change for each one of those. The future value, we don't know. That's what we're trying to figure out. The present value is how much we have today, which is $20,000. R is the interest rate, and the interest rate is going to be 0.09. And then N is going to be whatever each one needs, and then T will be 10. Okay, so let's look at A. The future value is going to be 20,000 times 1 plus 0.09 over, and then N in this case, for this one, is annually, so N equals 1. So 0.09 over 1, all to the 1 times 10. And then we're just going to type that in. When you type it in, you get $47,347.27. I'm just rounding as it is. There you go. And that's all A would be. That's all A is. How about that? Next, let's look at quarterly. For quarterly, N equals 4. So for this formula, it's 20,000 times 1 plus 0.09 over 4 to the 4 times 10. So type this in again, except this time divide by 4, and then do 4 times 10. And that'll give us $48,703.78. Not exactly, but I am rounding to the nearest cent. Yep. Good deal. Next, let's look at monthly. Remember, for monthly, N equals 12 in this case. So we're going to have A is equal to 20,000 times 1 plus 0.09 over 12, all to the 12 times 10. So again, just type that into the calculator exactly the way it is. And that'll give you $47,027.14. Awesome. Notice that each time we're actually increasing the amount of money that we get. In fact, it's somewhat significant. I mean, that's $2,000 difference. Well, $1,700, but close enough. Now let's go on to letter D, and on D we have N as 365. So for letter D, we have A equals 20,000 times 1 plus 0.09 divided by 365, all to the 365 times 12. Nope. Times 10. There we go. So let's just go ahead and type that in. That'll give you $49,186.61. Okay, good. Now, let's look at what's happening here. For this one time a year, it's $47,347. So $47,300, let's say that. For the next one, by just going to 4 times a year, we've actually increased the amount of money that we get by $1,400. But, adding on even more than that, going to 12, that's tripling the amount that we had. We are actually only increasing the amount that we got from the previous one by 300. Not very much. And then going from 12 to 365, still more than tripling. We're actually only increasing by a little around 160 bucks. So we're actually decreasing the amount that we're increasing over time as the number of compounding events increases. In fact, it's increasing dramatically. So what's important to see is that there's actually going to be a limit here, and that limit is going to occur because for E, it compounds continuously. That word continuously is very important. So the formula here is going to be A equals P E to the RT. Now that E is approximately 2.718281828. Now it just keeps going forever and ever. It doesn't repeat the 1828, but it just happens to look that way for now. E is like pi. Pi is irrational, which means it continues forever and it doesn't repeat itself. Well, there's no pattern to repeat itself, and that's pretty much it. It can never be written as a fraction. And so here, notice that we have a base of E with an exponent of R times T. There is no N because technically for the compounded continuously, N is infinity. So this is actually the formula that we have for an infinite number of compounding events per year. And so that word continuously is very important here. So P is equal to 20,000, and then E to the 0.09 times 10. In other words, 0.9. And some people find it a little bit weird to just type this in. So I'm going to go ahead and type this in now, and then I'll show you again on the calculator in a little bit. So just type it in. There we go. And so the future value is going to be $49,192.06. And this actually represents the maximum amount of money that you can possibly get at this particular interest rate of 9%. Okay, so it's $49,192.06. And that's even from just 365. Notice that that's really just an increase of $6. That's not much, especially for changing from 365 going up to infinity. I mean, that's literally an infinite amount more. So, all right, well, here are the answers. And now that we see this, I want to go ahead and go back to the calculator, and I'm going to go ahead and show you how to type in an E on the calculator. But I just wanted you to see this because, well, no, we don't have to come back to this. All right, I'll see you there. All right, we are back. Now, E exists on the calculator in a couple of different places. First, you can do second division. And just click enter, and that gives you 2.718281828, which is what I told you E was approximately. But there's another way of getting it, and see this ln button there? That E to the x power is written there. That base of E should be a clue there. So second ln means E to some power, which means you have to actually type that in. So I would do E to the first power would give us 2.718281828. Good. So if we wanted to type in the last formula, we would do 20,000, and then second ln to give us E to some power, and then just type in 0.09, the interest rate, times the time of 10 years, and click enter. And that gives us $49,192.06. And again, I'm just rounding at the nearest penny. Alrighty, well, that's pretty much it. I'll see you in the next video. Have fun.